relation between current density and mobility. Now we know that current density J is equal to I bata A. That is current passing normally through the unit cross section is current density. And we have calculated I in terms of drift velocity. I was equal to N into E into A into Vd divided by A. This A cancels. So the J will be equal to N E into Vd. Now we know that the drift velocity Vd per unit electrical field is mobility. So mobility mu is equal to Vd divided I, or Vd is equal to mu into E. Now substituting Vd is equal to mu into E in this equation. So J will be equal to Ne mu into E. So the relation between mobility and current density is J vector is equal to small n into small e into mu into E. The direction of electrical vector is the same as J. So this is the relation between current density and mobility. Now if the current is constant in a conductor and its area of cross section is not same. This is the conductor. Here at the entry point its area of cross section is A, and at this point its area of cross section is A dash. Here the drift velocity while entering is Vd, and at exit the drift velocity is Vd dash. Now we know that current is equal to NEAVD. So current is equal to NEAVD. Now N is the number of free electrons per unit volume, that is constant. The charge of electron is constant. If current is constant, then A into Vd will be constant. So A into Vd will be constant. So we can write A into Vd will be equal to A dash Vd dash. Here A into Vd, here A dash V dash. So V dash will be equal to, so we can write here V dash is equal to V dash Vd dash is equal to A divided by A dash into Vd. So since A dash is more than A, so this will be greater. So Vd dash will be greater than Vd. So smaller is the area, more is the drift velocity. Larger is the area of cross section, less is the drift velocity. So we can say if area increases, then drift velocity decreases. So if A increases, drift velocity decreases. A decreases, drift velocity increases. So for the constant current in the conductor where area of cross section is different, then the drift velocity will be more for that area whose area of cross section is less. Now we will find the relation between drift velocity and potential difference. Relation between drift velocity and potential difference. Now we have derived that drift velocity Vd is equal to E bata m into tau into E. Now suppose this is the conductor and V voltage is applied here. L is the length of the conductor. Then the electrical field will be equal to V bata M. So electrical field will be, so we can write Vd is equal to E bata M tau, and in place of E we can write V bata M. So V VD will be equal to small e into 2 bata m V bata L, or we can write this is VD is equal to small e 2 m into L multiplied by V. So VD is proportional to V. Means if the potential difference across this end is more, then drift velocity will be more. So we can say drift velocity is proportional to the potential difference across the conductor. Now we take a numerical example for drift velocity. Now suppose it is given that the length of conductor is 10 meters. The voltage length is 10 meter. V is 10 volt. V is 10 volt. And 2 is 10 raised to minus 14 seconds. Then Vd will be equal to small e, the charge of electron, that is 1.6 10 is minus 50, into 2 10 raised to minus 14 into electrical field 10 divided by mass of the electron 9.1 into 10 raised to minus 13 into 10. 10 cancel. If we solve it, then we will get this is equal to 0.5 centimeter per second. So, or we can write that it is 0.5 into 10 raised to minus 2 meter per second. So it shows that drift velocity is very small in comparison to the thermal velocity, which is of the order of 10 raised to 4 to 10 raised to 5 meter per second. Now we take another example, a problem, and we have to find the number of electrons per unit volume for the copper. It is given that the density of copper is 9 into 10 raised to power 3 kilogram per meter cube. The atomic mass of copper is 63.5 AMU. So, in 1 AMU, the number of atom is equal to Avogadro number. It means that in 63.5 grams of copper, the number of atoms of the copper will be equal to Avogadro number, which is equal to 6 into 10 raised to power 23. So, number of atoms of copper in 1 gram will be equal to 6 into 10 raised to power 23 divided by 63.5. So, this will be the number of atoms of copper in 1 gram of copper. Now, density, what is density? Density is mass per unit volume. So, density will be equal to m bata v, and density is given equal to 9 into 10 to the power 3 kilogram per meter cube. So, for unit volume, the mass will be 9 into 10 to the power 3 kilogram. So, the number of free electrons per unit volume will be equal to density multiplied by number of electrons in 1 gram. So density is 9 into 10 raised to power 3 into 6 into 10 raised to 20. That is the Avogadro number divided by 63.5, and it will be equal to 8.5 into 10 raised to power 28. So this will be the volume density of free electron in copper. We have found it. Now we want to find a relation, and we have to derive the Ohm's law using free electron theory. Now from free electron theory, we know that the current is equal to N into E into A into V, where N is the number density of the electron, E is the charge of electron, A is the area of cross section of the conductor, and Vd is the drift velocity. This is the equation number 1. We we also know that drift velocity is equal to E divided by m into capital E multiplied by 2. This is the result. Number 2. So I is equal to NE, we substitute the value of VD, NE A E bata M into 2 into E. So this will be equal to N E square 2A divided by M into E. Now we know that electrical field is V per unit length. So we substitute it. So here we will substitute the value of E, which is equal to V beta L. So we can find V will be equal to M divided by E square N2 multiplied by L beta A into A. So now for the given material, mass of the electron is constant, the charge of electron is constant, the electron density for that particular metal is constant, for the particular temperature 2 is constant, length and area of cross section is also constant. So these all quantities are constant quantity. So we can say that V is proportional to I. So this is nothing but a Ohm's law. By the Ohm's law we know that if the physical condition of the conductor remains constant, then the potential difference across the conductor is proportional to the current flowing through it. So V is proportional to I, or V is equal to I into R. R is the resistance, which is the property of the material which opposes the flow of charge from, or flow of the current through it. So if we compare this equation and this equation, then this quantity will be equal to R. So R will be equal to M divided by E square N to L beta A. So here now M is constant, N is constant, N is constant, 2 is constant. So this quantity is constant. So we can say R is proportional to N. R is inversely proportional to L. So the resistance will be more if the length of the conductor is more. If resistance of the conductor will be less if area of cross section is more. So R is equal to M divided by E square N into 2 into L beta A. So this quantity is constant. M is constant, E is constant, N is constant, 2 is constant for particular temperature and for particular metal. Therefore, this quantity is equal to the conductivity, because we know that R is equal to rho into L beta A. Now if we compare these two, then R which was equal to M beta E square to into N L beta A. So this quantity will be equal to resistivity. Rho is equal to M beta E square 2 into N. So this will be the resistivity. And what is the conductivity? Conductivity is equal to 1 beta rho. So this will be equal to M beta E square, E square 2 into N divided by N. So conductivity is sigma. So sigma is equal to 0. So here we see that the sigma, the conductivity and the resistivity of the material is constant because M is constant, E is constant, N is constant and 2 is constant for particular temperature. So we can say the resistivity and conductivity both are constant for a particular temperature for the particular conductor. Now if temperature increases, what will happen? When temperature will increase, the atoms which are in the lattice, they will start vibrating and their vibration will be more and it will be, we can say, the vibrations of atom will be vigorous. Then the vibration of vibration of atom which are fixed in the lattice is vigorous, then the it will decrease. The relaxation time will be decreased. So it will take less time to collide with the atom. Therefore, as the temperature increases, temperature T increases, then relaxation time decreases. And relaxation time decreases means क्या होगा? The resistivity will increase and conductivity will decrease. So, as the temperature of the conductor increases, it means that the relaxation time will decrease because there will be a vigorous motion of the atoms which are fixed to the lattice, and due to this vigorous motion, the time for the collision or the average time for the collision of electron from one atom to another atom, that is relaxation time, that average time will decrease. So when T increases, the relaxation time decreases. Therefore, the resistivity will increase because it is in the denominator, and conductivity will be decreased because 2 is in the numerator. So hence we can say that the resistivity and conductivity of the material depends upon the temperature, and it can also be explained by the theory of free electron. Chalo.